Namaste student. Today we're going to see limits of trigonometric function and the proof of this tree statement, and using this statement we're going to solve few problems. So our basic fundamental proof would be this one, and using this one rest two will be proved. Let's see how we're going to prove this one. To prove this one we're going to take circle or unit circle. So generally we'll take the circle. So if we'll take one circle and the measure should be in a radian, okay, radius r, here angle will be in a radian. Now you join these two parts AB, you write here, you take one right angle here, join it, extend here from A to C, join AB. So what you can find here, and give a name O as a center name. Okay, now what you can find, the area of this triangle AOB, area of the triangle AOB, area of the sector OAB. The sector would be what? If I take a circle, if I take this part, this is the sector. I hope you will know. And sector formula is theta by 360 pi r square. As we are discussing about the radian, so these two cancel each other. Okay, the pi and this cancel, will get here 2, that is theta r square by 2, and theta will work as a x. So this will be less than, this whole thing is greater than this part, triangle part. So we'll get area of sector AOB, which is smaller than area of the bigger triangle, that is BCO. We are taking this is right angle triangle. Yes, we can write area of triangle BOC. So now what you can get from here, the area of triangle AOB can be written as half into base. If I go in this one, what I can find, already we have seen in the class 10, we have already proved as it is a isosceles triangle. So we'll get here half r square sine theta. You remember, I thought half r square sine theta. Already we have proved this one. We have a video for this, how to find the area of triangle AOB. Okay, next, area of sector we have got here, theta will work as a x here, x r square by 2 is less than equals to triangle BOC, base, this is your base and this is your height. So if I take out this triangle 90 degree CBO here, so we know that 10, as it is written here x, so 10x equals to BC by OB. OB means here R, that means I can write BC equals to R 10x. So this part is half, area of triangle is half, base would be your OB. So at the place of OB we can write R into BC, that is the height, that is R 10x. So this gives us what? Half r square, half r square, half r square. So we are getting common, so we'll take out this all. We have here sine theta, not theta, we have here sine x, as we are taking this theta as x here in radian form. So sine x is less than equals to x, less than equals to 10x. Now divide the whole inequalities by sine x. So we'll get here 1 x by sine x divided by 10x by sine x. Now what you can find, 10x can be written as sin x by cos x, sin x cancel, we'll get here 1 by cos x. So 1 less than equals to x by sin x less than equals to 1 by cos x. Now we'll take the reciprocal of it all. If we take the reciprocal, sign will be in the reverse direction. That means 1 greater than equals to sin x by x greater than equals to cos x. Now you take limit in all part. So what will you going to get? Limit x tends to 0, 1 greater than equals to limit x tends to 0 sin x by x, which is our target. You can see here limit sin x by x as x tends to 0. That was our target. Now we are here greater than equals to limit as x tends to 0 cos x. So what will you going to get? As we don't have any variables, so it will give us 1 only. Let it be the way it is. That is our target. And this, if you substitute the value here, you will get cos 0. Cos 0 means what? So 1. Now see, limit sin x by x as x tends to 0 is greater than 1, less than 1. There is one theorem, that is a sandwich theorem or skew theorem. It says that if the both sides are equal, this implies what? Limit x tends to 0 sin x by x equals to 1. It says by sandwich theorem. Okay, so or you can easily see that sin x by x greater than equals to 1 and less than equals to 1. It is possible only when sin x by x limit x tends to equals to 1. Then only this statement, this inequality will be valid. Otherwise it cannot. I hope it is clear to all of you. So we have already got the result for the first one. Now the next one we'll see. Second one, if I take here limit x tends to 0, 1 minus cos x by x. We know that 1 minus cos x can be written as what, sir? I hope you remember one formula, that is cos 2x equals to what? Cos square x minus sin square x. This can be written as 1 minus sin square x minus sin square x. This gives us 1 minus 2 sin square x. Now you take this 2 sin square x this side, we get 2 sin square x equals to 1, and take this one cos 2x this side, we are getting this one. As right now we have what? At the place of 2x we have x. So what will we do? We'll divide it by 2, divided by 2. Inside, remember, not by 2. Sin x by 2 whole square is there. So here sin x 2x by 2, that means it will cancel each other. We'll get 2 sin square x by 2, 1 minus cos x. That means we can write at the place of this, that is 2 sin square x by 2 divided by x. Now you take here 2 into 2 like that, multiplying numerator and denominator by 2. Now these two cancel each other. We have here okay one more thing. So what we're going to get, we'll take here sin x is there. Okay, so we'll break it here like limit x tends to 0. We can write here sin x by 2 by x by 2 as 2 to cancel this x by 2. Sin square x by 2 is there, that means we can write 2 times, that is sin x by 2. Now we know that product rule of limits. So limit x tends to 0, x by 2 will take here, sin x by 2 by x by 2, limit x by 2 tends to 0, sin x by 2. As x tends to 0 imply x by 2 also tends to 0. See, if you see here, if you put the x equals to 0, you will get 0 by 2, that means 0 you will get. Means if x tends to 0, then x by 2 also tends to 0. So we can change the limit here. So this give us 1, and if you substitute the value here, sin 0 means this whole thing will be 0, sin 0 means 0, and we'll get here result 0. That is our proof, second proof. Now we'll enter into the third one. Okay, let's see, it's quite easy. So if I'll take here limit x tends to 0, 10x by x, we can write sin x by x into 1 by cos x. Why is that? Because sin 10x can be written as sin x by cos x. Now we'll apply product rule here, that is limit x tends to 0, sin x by x into limit x tends to 0, 1 by cos x. So if we substitute the value here, this is the standard limit form, so we'll get here 1 into, if we substitute the value here, x value, that means cos 0 means 1, 1 by 1 give us 1 only, so 1 into 1 give us 1. That is our proof. Now using this three concept, we're going to solve few problems. Here we have, let's see one by one. The first one, so we can see the first one. Okay, the first one is limit x tends to 0, sin 4x by sin 2x. So what we're going to do, we'll take here, see, if we'll get limit x tends to 0, sin x by x, means here both things should be same, then only we can write here 1. Remember, both things means x, this must be same, then we'll get 1. So what we're going to do, our target is that we'll take here sin 4x by 4x, we'll take here, then we have to multiply to make it balance, so 4x. Similarly, sin 2x is there, we'll divide it by 2x and we'll multiply here 2x. Now this part and this part cancel each other, x cancel, 2 2 ja 4, so we'll get 2 here, and 2 is a constant, it will come out, so it will be outside of this. We have limit x tends to 0, sin 4x by 4x divided by sin 2x by 2x, the whole thing. Okay, now this limit will be divided, we'll use quotient rule, that means limit 4x tends to 0, sin 4x by 4x divided by limit 2x tends to 0, sin 2x by 2x. Now you may ask, sir, how could you write here 4x and 2x, as it was x tends to 0, now you are writing 4x tends to 0. Yes, as x tends to 0, we can see that 2x also tends to 0 and 4x also tends to 0. If you substitute the value of x here 0, you will get 0 only, so it will not affect your result if you change the limit here, no problem. Now this whole thing become this standard form, so at the place we can write 1 divided by 1 and we'll get our answer 2. I hope it is clear. Now we'll enter into the next problem. Okay, one by one we'll see here. Let's see next problem. We'll see the problem one, second one we'll see. There is limit sin a x by bx as x tends to 0. So how are we going to solve? See here, b is what? Constant, so let it be outside of the limit part. So 1 by b, we have here limit x tends to 0. We have sine a. See here, sine ax. So we need here a. X is already there, so no need to take. As we are taking a by ourselves to get the standard form, so we have to multiply a also. Multiply a at numerator and denominator to make it balance. Now see, this a is also constant, so take out this one. We'll get a by b, and we have here x tends to 0 sine ax by ax. But at the place of x, we can write here a, and we say here, since a tends to 0, sorry, not a, x tends to 0, ax must be tends to 0, as a is non-zero number, so it must be tends to 0. If we substitute the value x here 0, we'll get 0 only. Now this become a standard form, so we can replace it by 1 and we'll get a by b, and in the bracket you mention here limit x tends to 0 sine x by x equals to 1. Okay, now next we'll see the third one. It's very interesting. Third one also we'll change here limit totally. So what we have, we can see that sine pi minus x divided by pi into pi minus x. If we'll write here pi minus x as t, let take it as t, let pi minus x as t, then what, this become limit t tends to 0 sine t by pi t. Now the question will be arise, so how could you write t tends to 0? Look at here, as we write here as x tends to pi, and the question it is given here as x tends to pi. That means if I substitute the value of x as pi, so pi minus pi give us what? 0. As x tends to pi, then t also tends to what? 0. This imply then what? Then t must be tends to 0. That's why limit change. Okay, and now you take out pi outside, 1 by pi, we have limit t tends to 0 sine t by t. This gives us standard form. We have here 1 by pi into 1 equals to 1 by pi. That is our answer. Okay, next question we'll see, that is this one. These two are quite similar. Okay, let's see here. One by one we'll see these all, and you need to try this 3. If possible, you pause the video, you try by yourself, and then you check your answer, and it will be better. Okay, so next we'll enter into the fourth one. So we'll see here the fourth one, that is what's limit x tends to 0, that is cos 2x minus 1 by cos x minus 1. Already we have seen this formula. Cos 2x can be written as 1 minus, so there's a formula 1 minus sine square x. Okay, 2 would be there, 2 minus 1 divided by 1 minus 2 sine square x by 2 minus 1. Why is that there is a x by 2? As there is x, that's why x by 2. Here 2x, that's why we are getting x. See this plus x minus x cancel each other, 2 cancel each other. We have here limit x tends to 0 sine square x by sine square x by 2. Okay, now what we are going to do, our target. So we have here limit x tends to 0 sine square x by, we can write here x square to make it here x square, balance it, and denominator x square sine x square is here. So what we'll do, x square by 4 means here 2, you take whole square, okay, into x square by 4 to make it balance. So this here we'll write, this give us what's this x square cancel, 4 will go up, we'll see here 4 up, so you can take out 4 directly outside, so 4 will be outside as it is a constant, so 4 will be outside. We'll get here sin square x by x square by sin square x by 2 by x by 2 ka whole square. So limit will be in a dividing form, so it will distribute, and there's a power rule also. We'll apply the power rule. We'll get here limit x tends to 0 sin x by x whole square, and this limit will go here also. Quotient rule and power rule both will apply it together. That means here we'll get limit x tends to 0 sin x by 2 by x by 2 and the whole square. Okay, and this gives us 1 by 1 equals to 4. That is our answer. So next we'll see the fifth one. Okay, the fifth one, what it says. The next page we'll see. So limit as x tends to 0 ax plus x cos x divided by b sin x. So how are you going to do it? So this is numerator part, this is denominator part. In a quotient rule will apply here. So if we apply the quotient rule, or you can do like that also, but it is quite hectic. It's better what you do, you break it, split it here. So first we'll split, let it be limit x tends to 0, we'll split it here, ax by b sin x plus addition rule will apply. Okay, first let it break it, x cos x by b sin x, break it here. Now addition rule you apply. So what we're going to get, addition rule plus constant rule also. So a by b is constant here, it will be outside. A by b limit x tends to 0 x by sin x, this one we have, plus 1 by b will be outside, limit x tends to 0 cos x, and this x by sin x. So what we're going to do, we'll take here x here, multiply x to make it sin x by x into x. We'll get this form. We need this form. To get this one, we'll multiply up and bottom by x to make it balance. Similarly here, x into x. Now this x will cancel each other. This x cancel each other. So what we have, we'll apply the quotient rule. There is a 1 by sin x by x, and here cos x by sin x by x. So quotient rule we apply on both. So as it is 1, so it will give us 1 only. So we'll take here 1 by limit x tends to 0 sin x by x, that we are getting, plus 1 by b will be there, into we'll get here 1 by limit x tends to 0 sin x by x, and into limit will be applied here also, limit x tends to 0 cos x. So what result we are going to get, a by b into 1 by 1 plus 1 by b into 1 by 1 into 1. As we substitute the value here 0, we will get cos 0 equals to 1. So we'll get here 1. Now LCM we are getting b. See here, a by b plus 1 by b, and you take LCM b, a plus 1. That is our answer for the fifth one. Now next we'll see sixth one. So limit x tends to pi by 2, 10 to x by x minus pi by 2. So I'll give the answer directly, as video is quite getting longer. So You just see the video. So here we have the answer, direct answer. I'll explain a little bit. See here, x minus pi by 2 can be written as t. So take the LCM, 2x minus pi by 2. So now if we substitute x by pi by 2, so what you will can see that pi 2 to cancel each other, pi minus pi give us 0 by 2 and it tends to 0. That means if x tends to pi by 2, then t tends to 0. And at the place of 2x, we can replace here. See here, this 2 will go here. So we'll get 2t and pi will come this side. So 2 pi also actually. Here we'll get a little mistake is there. Sorry, little mistake is there. So we'll get here what 2t. So 2 will be here. Okay, and pi plus 2t give us 2t. So we have here t. So we'll take here 2 and 1 2 would be multiplied here. And here we'll take 2. As t tends to 0, so 2t tends to 0. So this 2 will be outside 2 and this will get here 2. Limit 2t tends to 0, 10 2t by 2t, and this give us 1. 2 into 1 give us 2. That is our answer. Okay, and next problem, this and this. So I have done this too. You can do this one by yourself also, or I'll show now. Here we have the answer for this one. See here what I have done. I have taken the limit using the quotient rule, so and addition rule also, applying the quotient rule first and then applying addition rule both together. So we are getting this. We have taken ax multiplying numerator and denominator by ax to get this standard form. So this gives us 1. Now we use product rule here. We are getting here 1 into limit x tends to ax. This, because of this rule, we are getting 1 here and 1 here. So after that, what we are getting, what now we'll take it common, that is limit x tends to 0, limit x tends to 0. So reverse of addition rule will apply here. So we are getting, and reverse of quotient rule will apply here, and this part cancel each other. We'll get here 1 and limit x tends to 0 give us 1, as there is no x, so we'll get here 1 only. That is our answer. Now you will say, so why, if you substitute the value here 0, if you substitute the value 0 and 0, what will get 0 by 0, which is indeterminate form. That's why you cannot apply that one. So we have to apply this concept to get our answer. Okay, so next this one, this already we have done. So I start which here. See, cosec can be written 1 by sine, cot can be written cos by sine, sine common, LCM we are taking 1 minus cos x, that can be written as 2 sine square x by 2. So this gives us this form, and we know that sine 2a equals to what, sir? 2 sine a cos a. That concept we have applied here. So x by sine x by 2, and there is a 2 times, 1 cancel, we are getting sine x by 2 only. So sine x by 2 cos x by 2 give us 10 x by 2. Now you substitute the value here. If you substitute the value here 0, so 10 0 by 2 give us 10 0 will get, and 10 0 give us 0 only. That is our answer. Okay, and next one, we see this one now at the end. So let's see. So now we'll take this problem. This is the last problem for us. So then we'll conclude the video. So what we have in the second number, that is limit x tends to 0, 1 minus cos mx by 1 minus cos nx. This can be written as, how? This can be written as 2 sine square mx by 2. So how could you say like this? As see here, 1 minus cos mx can be written as 1 minus cos 2m by x. This is, see, 2a. That is 1 minus cos 2x is the formula is 2 sine square x. That is the formula. So whatever would be inside, that will be here, x here. So this part we have. So that can be written as like this. Similarly, this can be written as sine square n x by 2. This is the whole bracket. Okay, now the two cancel each other, so and we'll take the power rule also here, apply quotient rule, will apply two cancel, we'll apply quotient rule and then power rule. So we have x tends to 0 sine m x by 2, that we can apply here. Similarly, okay, so what we are getting, there's a square inside of that, and similarly it will be limit x tends to 0 sine n x by 2, and the whole thing will take here square like that. Now in this we'll apply here normal concept, that is sine mx by 2. So we'll take here mx by 2 and multiply here mx by 2. Similarly in the denominator part also we'll do like sine nx by 2. So we'll divide nx by 2 and we'll multiply by nx by 2 whole square. Okay, now this part give us what's this part give us 1 and this give us 1. How could you say? We'll break it now. Limit, this is mx by 2 tends to 0 sine mx by 2 mx by 2. So here and take out here limit x tends to 0 m square x square by 4 we're getting here. Okay, similarly we're skipping the step here. Similarly here we'll get, so how could you say that this one as x tends to 0, if you substitute the value like x tends to 0, this means m by 2 into x also tends to 0. Okay, multiplying any constant term with this, but we'll get 0 only. So here similarly limit n x by 2 tends to 0 sine nx by 2 by sine nx by 2 the whole square, and this gives us limit x tends to 0 n square by x square by 4. So this gives us 1 by 1 into, we'll take out this 4 part, this part constant part. So we'll take out constant part, that is m square by 4 by n square by 4 similarly, and we'll get here limit x tends to 0 x square by limit x tends to 0 x square. This gives us 1. This here we are getting 4 cancel. Our answer is m square by n square. That is our answer. I hope it is clear. Thank you.